Okay, welcome folks to another ARW discussion. I see we got Rusty Knox and JC Machine Shop and Frank Ward and Almost Machining and Al and David Fairbanks. I sorry guys, I got to talking and you know how that is. The wife won't let me talk at home because she says I forget what I'm doing. Uh, but anyway, we've got some YouTube star power here for our guests today. We've got Keith Rucker. Everybody knows him, and I'm sure everybody's subscribed to his channel for years, like I have been. And we've got Quinn Dunki, who is the only active lady machinist on the North American continent. And and we've got Uchel, who's my favorite. So there you go. And we have, of course, Chuck and Billy Knox and James Clow. And James Clow is our electronics genius. So you know, we're well set up here. And we were going to talk about gears, and the guy that I want to talk to first about gears is Keith Rucker. I've been watching your setup on that spiral gear transmission thing, and is it ready to go?
Yeah, it's pretty much ready to go. I've got a few little things I've still got to deal with, but for the most part, it's just yeah, it's just needing to get it hooked up and try it out.
I've been looking forward to it. So, are you gonna? Do you have a specific spiral gear in mind that you're gonna make starting off?
Yeah, so my plan is when I bought that K&T 3H milling machine, it came with a spiral head, or I got a spiral head for it, or a vertical head, and it was I didn't have the correct drive gear for that. I've got blueprints on how to exactly how to make it, but it's a spiral gear, and as you know, spiral gears are kind of complicated. I've never made a spiral gear before, and it just kind of led me down yet another rabbit hole where I said, okay, now I got to get my milling machine set up to cut spiral gears. So to do that, you need a lead attachment. Basically, what happens is while that gear is cutting, it's actually turning at the same time, and that's what gives that spiral. And at least in the mechanical setup that I've got a gearbox on the end that attaches to the whole drive system, and as that crank is turning on the end of the table, is also rotating in this drivetrain inside of that box on the end, which is connected to my milling machine, and then that, of course, rotates the gears that's being cut. It's quite complicated. You have to put a whole different set of gears in there inside of it for what they call leads, which is how much twist is going on as you're rotating. So anyway, it's going to be a challenge. My plan is that I'm probably going to cut my first gear out of some plastic. I just got some like some Delron, and I'm going to make it just like it's the I'm going to basically make a plastic version of the drive gear before I try to make it out of steel, just so that I can practice and kind of learn my process because like I said, I've never done one before and don't know exactly what I'm doing. So I figured I'll do a test run, and if everything goes right, we'll move on to making one out of steel.
There you
Keith,
go.
what kind of cutter do you use with that? Because you can't use like a normal involute gear cutter, right? If the
Yeah,
stock is twisting.
actually, you do. You use just a regular
Really?
involute gear cutter. Yep, yep,
Huh.
that's exactly right.
So it
And
doesn't it doesn't get like jammed up in there because the stock is turning while the cutter is engaged?
well, basically, what happens is that gully that is cutting out is just a little bit wider, but
Mm,
because it's cutting the whole time, yeah, it just kind of takes care of itself, and you end
interesting.
up with a matched. Both the top and bottom gear are going to be more or less the same. So anyway, that's kind of the way it works. At least the way I
Cool.
understand it works as of right now, and I've got a lot of playing around to do. I've got a friend of mine that I've met through YouTube and the internet or whatever that's actually been cutting some using a lead attachment, and he's been helping me out and kind of giving me some guidance on how to get started on it. But my biggest thing is I gotta take the time to get over there and do it. And as it seems to always be my problem, I have way too many projects and not enough time, and it's just got to work its way to the top of the list.
I was gonna say, how many active projects you got going right now?
Way too many.
Metal planer, the Stoker engine,
Yeah, exactly. So,
horizontal boring machine, the gear, or what we're just talking about there. Yeah, that's 4 that I can think of just off the top of my head.
yeah, that's a challenge I'm constantly fighting, and I'm really trying to focus on getting my metal planer done before I really go down the next rabbit hole. Even though I'm kind of partially down a couple other rabbit holes already, but yeah, I'll probably get the planer finished before I get back over onto the making the spiral gear. But hopefully by the end of this summer, maybe we'll be over there and playing around with it.
I actually shed a tear a little bit when I saw that you didn't have the right gear. When you got the gear and you thought it was the right one.
Yeah, so I purchased that vertical head, and the guy that I got it from, I've actually become very good friends with him. He's a super great guy up in Milwaukee, Wisconsin, and he actually worked for Kearney Trekker for 30 years. He was over their rebuilding department when he retired, or I guess actually when K&T shut down. It really wasn't a retirement, but he was rebuilding old machines and whatever. But he started there in the early 1960s, and he is a walking encyclopedia when it comes to K&T stuff, and he thought it was the right gear that went with that head for my machine, and I did too. But once we got it into the shop and put it in there, it was just a little bit different, and we started doing some further research, and sure enough, it wasn't the right gear. That the gear I've got, I'm not exactly sure which machine and head, the combination that it fits, but one of the challenges with all those Kearney Trekker machines, they offered about 6 different versions of vertical heads, and of course they had I don't know how many different size machines, and you start looking at all the combinations, and there's a lot of different gears out there to drive those vertical heads.
I was wondering, I know that you ended, restoring all this big industrial stuff. Have you given any thought to buying a CNC machine?
I've got a CNC machine. It's a 3D printer.
Well,
if that counts.
well, there's a lot of us with those. But
It counts.
It does.
Yeah, I guess never say never, but it's not something right now that I'm just really wanting to go down. It's yet another rabbit hole, and I'm old school. I learned how to do machining on manual machines, and that's kind of what I do, and that's kind of what I specialize in. So I'm by no means anti CNC. In today's modern world, in the manufacturing world, I mean CNC is about the only way to go. But I honestly feel like with the kind of work that I do, which is mostly repair work and one-off jobs and so forth like that, I feel like I can go out there and make a part on a manual machine faster than you can draw it up, program it, proof it out, and everything else on a CNC machine. It'd be a totally different story if I was, making, tens or hundreds or thousands of the same part. But for one-off work, I like the manual stuff, so that's the direction I'm going to probably stick in.
okay,
And I got plenty of friends with CNC machines, so when I do have that unusual need for one, I can usually reach out to one of those guys and they'll help me.
Yeah, I totally recognize that. I mean, the CNC machine is great if you want to make something with a bunch of curved surfaces on it. That's kind of hard to do in a manual machine. You can do it, but it requires a lot more setup, and it's easy to crank that stuff out. But even just grabbing a piece of stock and squaring it up, you got to go to a bunch of work. You got to drive the thing around. You got to figure out what your feeds and speeds are. And when all I had was a CNC mill, I just really missed being able to throw something in the vise and grab the cranks and just make it. And that, so you can see I've got a manual machine again, manual mill, because I've got both. I just couldn't do without it.
People are always asking me why I don't have a CNC machine or when am I going to convert my mill to CNC. But the answer I always give is that I'm doing this stuff to get away from the computer largely because that's my day job, and CNC turns everything back into a software problem, and I'm here to get away from software and use my hands for things. So that's why
And
I
it's
like
terrifying.
manual.
I'm a little torn on the subject because I
You
wanted
sit
to
there, you put your hand on the e-stop, you hit the go button, and you hope.
Is it Stefan says that on the modern high-speed CNC machines, the e-stop is entirely decorative. Like you'll never even get there before the machine destroys itself.
That's pretty much the truth, yeah. For me, a big part of what I like about building stuff in the machine shop is the challenge of figuring out how to do it. And I prefer to use the computer up here, that gray matter between my ears, rather than the electronic device that sits there that does all my thinking for me. For me, it's a challenge, and it's kind of like making these spiral gears. Yeah, I've never done one. I've made tons of gears. I understand the process of making gears. I understand the process of making a spiral gear, and it would probably be a lot easier just to program it in and put it on a CNC machine and do it. But for me, yeah, I want to figure out how they used to do it a long time ago, and that's going to be on using a manual machine.
Yeah, I remember when you one time you put your spreadsheet up there that you got for calculating the gears.
Yeah.
So I reverse engineered it from what I could blow up my screen to do. So now I've got a spreadsheet.
Good. Well, a lot of people ask me if I would share the spreadsheet, and I have shared it with a few folks, but I challenge you. Go do the math. I mean, if you want to learn how to make gears, you need to understand the math in there. Go get your machinery's handbook out, and every formula's in there. And once you go through that process, it really kind of helps you better understand what's going on and what you're doing. So there you go. I see. Quinn,
Oh, I've got that
gear
same book.
Yeah, I was just going to highly recommend this book if anyone's interested. It's like a great gear making for dummies kind of thing. It distills everything down into a really easy to understand kind of format. It's great.
Yeah, there's
I've
a
got
bunch of really good references. Like I said, Machinery's Handbook has got almost everything you need to know in it. Actually, I have a copy of a manual for the Navy, for machinists in the Navy, and it really takes gear making and breaks it down in a fairly simple, easy to read way, and it's got all the math and everything in there, and I found that to be a really good reference. You can pull up that U.S. Navy machinery's manual. It's available on the internet in PDF format, but that's a really good book too. And I don't know, I've got a whole library of stuff like that I dig through all the time.
I've been wanting to do some gear cutting for quite a while for the robotic stuff, but getting those individual cutters has always seemed hard to find and expensive proposition. I saw a couple guys doing gears using single point cutting, where they'll take a high speed steel and grind the profile in it and put it in something like a fly cutter and go to town. And that's about the only way I can think to do it on my setup without investing in those cutters like you have, Keith.
Yeah,
that fly cutter method, it works just fine. It's just slower, but if you're not in a hurry, there's absolutely nothing wrong with that at all.
I always recommend people go and read the old model engineering books from like the 30s and 40s, because those guys were making everything on a lathe and with basically zero budget, right? So, and they were cutting gears and they were doing all of this stuff. So yeah, they'll show, those books will show you how to rig up a fly cutter with a drill motor or something, and on your lathe using a tooth on your change gears as an indexer. This stuff can all be done with very little tooling if you're creative about it. And those books are great inspiration for that. And also they're fun for the absolutely terrifying faceplate setups, because they didn't have milling machines. So it's terrifying what they would do on their faceplates.
I think Quinn, that's a very interesting point you touched on. Is today, if you look at it, just your options for tooling is just vastly more broad than what they used to be, right? So in a way, I find myself spoiled by oh, look at that, I want to go buy it. Oh, that'll make it easy. But the older days, people actually had to create tools and do what they can with the minimum materials that they had, and in a way we're just spoiled, I feel like.
Yeah, Yeah, in one of those old books, like every time I think, oh, there's no way to do this without buying some expensive tool, I look in those books and I'm proven wrong yet again. The other day, I found an article on how to cut threads on a lathe that is not a screw cutting lathe. You know, in the very early ones, like the treadle lathes, didn't have lead screws, and they cut threads on those things. There's a way to do it. You know, they weren't super accurate threads, but you can do it. So there's really very little limits. Once you've got a spindle, you know, and some high speed steel, like you can figure out every other aspect of the operation.
Well, if you think about it, you know, the very first threading lathe with a threaded lead screw, how did they make that threaded lead screw for the very first lathe, right?
Magic.
With a file, probably.
I call those Lipton mills. I saw Tom Lipton build a bullet vise with a file, you know, mostly.
Yeah, poor guy with a hand file making that lead screw, right?
I wouldn't doubt it.
Yeah, when there's a will, there's a way. I can tell you so many examples of doing jobs on machines that weren't intended to do that job, but you just, you know, sometimes you just got to get it done with what you got. And you know, anyway, I remember back in the 1980s when I was working in the machine shop, we had a job where we were needing to thread a lead into a drum. It was a cable drum went on a roll-up doors. It was an aluminum casting that we machined out, and it had a lead in the bottom for that cable to wrap around, basically almost like a thread in there. And we didn't have a lathe big enough that we could cut that thread in there, so we actually rigged up a thing and was cutting it on a milling machine. And almost like my lead attachment, except we built it all. We put gears on there that were driven into the table as it moved. It rotated the drum as the table went across, and we were doing it on a horizontal milling machine. So, you know, like I said, if there's a will, there's a way. It's ironic that probably a couple of years after I left the machine shop, my boss ended up getting a CNC machine, and he got it for that job because he could do that particular job so much better with CNC than the way we were doing it. But we got it done for years on a horizontal milling machine, cutting threads.
Yeah. So Keith, the drive gear for your KNT is going to have to be pretty beefy, pretty strong, and yet it's going to have to be something that you can machine. What kind of material are you going to have to use to make it work?
You know, that's a good question. I've got a copy of the original blueprints from K&T, and I can't remember what grade steel it is, but according to the original one, you know, it would have been case hardened after it was machined, and then they actually would have ground the threads in, or the gear teeth in after everything was hardened. Obviously, I'm not set up to do thread or grinding of gear teeth, particularly spiral gears or something like that. And you know, I'm just going to make it out of probably some 4140, something like that, and just not even harden it. Yeah. And you know, and I know a lot of people are going to tell me I'm doing it wrong, but at the end of the day, that machine, it's not like it's going to be set up and cranking out the same part 24 hours a day, 7 days a week for years and years and years, where you would need a hardened gear. It's going to be used for the occasional one-off job, and I guarantee you I'll never wear it out. So I'm just going to go that route.
Well, even if you wear it out, you can build another one now, since you'll have the capability.
There you go.
Because you're spreading the wear across so many machines.
Hey guys, real quick, we got a little issue here at home. I got to bail out. My wife had an accident, so catch everybody. She's okay though, but I gotta go.
Bye, Chuck.
Okay, bye, Chuck. Boy, the board of directors. He was the only guy from the board of directors, and he's gone now.
Yeah. Yep. There's going back to the whole art of there are videos on YouTube it talks about what precision meant in the 1800s. And how people were able to create such precise equipments and things with technology that were very lagging, in the old days. And it's really interesting in that, in order for companies to make precise lathes and mills, they had to use equipment that were significantly less precise than what they're trying to make. And if you look at the whole industrial revolution and the time period, it's just amazing how they were able to just one up their current setup to where they need to be. I mean, how do you make these precision flat surfaces without having the technology to build something that precise? And you know, maybe it was alien technology, like the History Channel says.
Just
bootstrapping is always a hard thing to do, but it can be done.
It's
the
the chicken and egg thing.
handwork and continual iterative improvement. You take a couple surfaces, 3 surfaces, you get them pretty flat, and you start printing them against each other and scraping a little bit here and there, and you can come up with something that's completely flat or to whatever tolerance you need.
So,
yeah, and
there's
that's
a really good book. I don't know if y'all have ever seen the book that's been put out by Moore called Foundations of Mechanical Accuracy. If you haven't, you need to get a copy of that book. But it really goes into the history of precision and talks a lot about just these things right here about how they went from one level to another level, and using 3 plates to make something flat. All that stuff is in there, but you can buy that if you go to the Moore is still in business. Of course, they made machinery. They still make machinery. The Moore jig bores was one that they were kind of famous for. But you can go to their website and order that book right now. And if you're interested in precision, I would highly recommend that you get that book, because it's got some eye-opening stuff in there.
Yeah, and I think that's really the genius of the lathe too, that I think a lot of, especially folks new to machining, don't necessarily appreciate the fact that the lathe can create a surface that is more precise than the bearings in that lathe. And that's really the magic of it. As long as you turn down below the runout, you can create a perfect surface with a machine that is not itself perfect. And once you can do that, plus hand scraping, like you're there. Like now it's just about time. I mean, hand scraping is slow, but you can build any machine that way. And everything we've done since is basically optimizations of those processes.
Yeah, I got to take a scraping class at some point. I really want to learn how to do that.
It's addictive.
That's what I'm afraid of. That's what I'm afraid of, Keith. Addiction. Well, when I got my mill, it was when it was new. I dared measure the run out on the spindle and just to see what it was. And Randy gave me a hard time. He says, "You're a brave man. He has measured the run out in his mill." And to what Quinn was talking about is, the person overcomes whatever the issues or shortcoming of your machine. I mean, does it really matter that you have a half thou run out if you compensate and you don't even think about it because you're used to what your machine does?
There's so much truth to that, and I mean, how many people have made good parts on worn out machines? I mean, most of us, particularly if you've worked on anything old. Goodness gracious! Again, going back to my days working in the machine shop, the newest machine we had in there would have been built during World War II, and a lot of that stuff was old flat belt machines from the late 1800s, and a lot of that machinery was literally worn out. But if you can make good parts on a worn out machine if you just know how to use that machine and you know what your limitations are, and okay, I'm getting down to the end. I got to make really light passes here or what have you. It's really surprising what you can do, and you can get better precision out of a machine than what that machine's probably really capable for in the grand scheme of things.
Certainly better than you could get if you were having to do it repeatedly and at high volume. If you can take your time. I've milled parts out of tool steel on my little Grizzly benchtop lathe down to 2/10, 3/10, and you can do that. But it takes time. You got to go slow and measure and use really sharp tools and have optimal geometry for the cuts. And but it's possible. And a lot of people look at that and just can't understand how you do it. That machine's not that accurate. No, it's not. But I know how it's going to behave, and I can walk it in, and I can get what I need out of it.
Yeah, you get to know your machine over time, and I remember hearing the story one time from a guy in a factory and that ran I don't remember what machine it was. He ran it for years and years and years, and somebody came in while he was off and couldn't make any good parts on it. And the guy came back and says, "How do you make this thing work?" He says, "Oh, when you get down to the final pass, you got to lean on it over here." And that kind of, and the other guy didn't know that. So, but it's little tricks like that. You get to know your machine. If you're running a machine all the time, you get to know it, and you can do good work on a machine that's probably not capable of doing that work. I know that sounds weird, but it's very true.
It's funny. Go ahead. Go ahead. I was going to say I kind of have the opposite problem, because my machines are very, very small and very lightweight, very similar to James's actually. And most people that watch my channel have not used machines that small, and so they don't understand how slow and how light you have to go with them. And so they will often, tell me, "Oh, why didn't you just do X?" And it's like, well, doing X, requires taking 100,000 passes, and I have to take 10,000 passes in steel, so that would have taken me 2 hours to do it the way you're describing. So it's a lot about it's a lot of light passes and a lot of going very slow. And I think that gets edited down into a video, and people don't always understand how these really small machines are very different than a Bridgeport or something like that.
Well, it's because guys like Keith with monster equipment, one pass, right? And that's what people get used to.
Yeah, well, I played around with both. Go ahead, Harold.
But even with a monster machine, you still have to take those light passes to get things finished. I mean, yeah.
Having played with both with your videos in particular, Quinn, the scale is really hard to judge. That little lathe that you've got, I've got the Grizzly Geo602, and it's actually bigger and heavier, but I couldn't see that because I look at the video, I'm scaling that, I'm interpreting in terms of the machine that I've got and thinking, wow, that seems kind of light. I know I can push mine harder, but I've got belt reduction. I've got a cog belt that, a bat gear equivalent that's not on there. The chuck's larger. And so it's just, you look at it on video and you just don't understand. You just can't see it. And even now knowing and having made that chuck key and sent it to you and then seeing that next to the machine, it's still just startling. You just don't appreciate the scale if you can't see it in person.
Well, they're baby machines, that's for sure.
Having used both lathes similar to James's, or actually identical to James's, in my 1340, and then of course my Geo704 and my Bridgeport, I've gotten a taste of both worlds, and I'm going to go for the bigger machines when I can because they're just easier to deal with, more travel, easier on that mill. I don't have to worry about the Z. I don't have to worry about long drill bits most of the time on that mill. On the lathe, geez, I don't even want to talk about that Grizzly. I got over that thing quick. The change gears is what really burned me out on that one.
Got a solution for you on that if you want.
I want to do that on the 1340 too.
Yeah, for me, it's space, right? I would absolutely have larger machines if I had the space, but I just don't. So I learned to make do with what I got.
Well, if I was working here out of my house and my little tool room, I'd still have to have small machines. But thankfully, with the makerspace, I've got a little bit more room than that now. So that's a good thing.
Yeah, the lathe I learned on was actually a hardened HLVH, which is fantastic machine. But I think today, if I bought one, I would really miss the electronic lead screw. I would miss just reaching over and changing the feeds and dialing the threads.
You want to talk about a small lathe? I've had the pleasure of playing with those little 7x10s from Harbor Freight or similar. Those things, they're kind of cute. They're kind of neat. They'll do work, but I wouldn't wish those on anyone.
Are they appropriate if you want to do something really small, like really small model engineering that you'd be getting all up inside the chuck on a bigger lathe, or is there really no place for it?
It's a kit.
Yeah, that's fair. It's a casting kit.
It's a casting kit. You need to, if you want to use it for model making, you really need to do a lot of work on it to get it up to spec, because the lead screws in it, I think they're somewhere between metric and imperial. I don't know what they really are. They're kind of horrible both ways. They just don't work. And they're kind of sloppy all over the place.
James?
Mr. Rucker, I'm a subscriber to Keith's site way back when he started, 2012 about, right? And one thing I like about vintagemachinery.org is anybody out here that home machinists or whatever, machinists in general, you can look up old time equipment on his site, and all the particulars, every name brands that you could think of that going back to the 19th century, and he's got a whole museum there too, right? And it's just one of the one of the long time first people on YouTube machinists that I can recall. The other Mr. Peep was probably one of the first, 2006, I think he started. So yeah, nice to see you guys. I'm a new subscriber to Quinn. I think I got Quinn mad at me. I left a comment about the T-nuts busting through the bottom, and then she mentioned that she made them special, and I think I mentioned it to her in an earlier one too about I just made up a bunch for my new rotary table. I got a Vertex 8-inch, a new one. I just got it at auction, and I always do that. In fact, I can show real quick. What I'm talking about, T-nut staking to the other people and the viewers in the view. When you stake it with a chisel, you knock out the bottom, you knock out the last two threads so that the stud doesn't protrude. And I used to work in a tool room, and we used to use milling machines, Bridgeports and index mills for production. And I was in the tool room making fixtures for them and the CNCs. And I've seen many of old machines where they blew the table up with, big guys cranking down on studs to tighten up their work and milling and blow the table. It'll pull a casting apart. So that's what we always did when we made clamps and everything.
And Mr. Pete was just talking about that on his video today.
What's that?
Yeah, you can also just don't cut the threads all the way through when you make a T-nut so that the bolt can't.
Yeah, they sell them like that too, right?
Yeah, the commercial ones you buy, the last thread is missing or they. I showed it in my T-nut video as well. You can also just take a punch and just screw up the last thread, basically, just make it so it doesn't work anymore.
So I put a 4-inch chuck on a 4-inch rotary table, similar to what you did, except I had to do some magic there to get so you could tighten up the little bolts. I had to undercut it and do some weird stuff because it was the same size. Always thought it was horrible just wasting that extra inch.
Yeah, I looked at a bunch of different ways people do it because I was wondering about that too. Like, do I have to use a chuck that's smaller than the table? The other strategy people use is you can get chucks that bolt through the front, and then you can just bolt it straight into the T-slots, and then the chuck can be the same size. That seems like a good thing. And I've seen people actually modify their chucks as well. Add, if there's room inside, you can just put bolts right through the whole chuck. I've seen people do that as well. So there's some creative solutions to that for sure.
I just wait for Quinn to do stuff so she can solve all my problems, and I just copy what she does, and I just do the same thing, and it works out perfect for me.
Well, we're in trouble because I'm waiting for you to solve my problems.
No,
I'm going to do to my bandsaw what you did to yours. That's great. I love that.
Oh
video.
yeah, I've been meaning to get back to the bandsaw for a long time.
Yeah, that's because that one video solves everything that I currently dislike about that saw. I love that saw, but it's got a few issues, and you fixed all of them. So I think that's great.
Well, good. Keith, I remember checking out your website when I was into woodworking. Don't tell anybody. It's amazing. I don't know if people know, but I mean, obviously, Keith's VintageMachinery.org has a lot of information for machining equipment, but there are a lot of information on woodworking equipment. So if you're restoring things, it's a great resource for that as well. And that's how I first became familiar with that website long before I got into machining.
Well, and the truth be known, the VintageMachinery.org website really kind of started out just with woodworking machinery. That was really where we started. In fact, it used to be there's a lot of history there, but it used to be owwm.com.
That's right.
I think. Yeah, and at some point in time, it was still probably back in the early 2000s, we decided to expand the site over to metalworking machinery, as well as some other stuff, steam and engines and motors. We got a bunch of stuff in there now, but we changed the name from OWWM, Old Woodworking Machines, to Vintage Machinery.
I'm proud to say that I used to check it out under the old name.
Yep. In fact, if you type in oww.com, I think it still goes over to Vintage Machinery. I think we still have that domain if I remember right.
Wow.
I was hoping maybe I could talk James into cranking up Fusion 360 and turning out a gear just for the heck of it on his CNC machine.
Yeah, well, I have not tried cutting gears. I have 3D printed timing belts, even down to pitches like GT2, and that has worked great. I've done a bunch of the MT3s, the 3mm metric pitch ones that I've used on the lathe for prototyping, and that's worked well. But I've never attempted gears aside from, I guess, the old herringbone gears that were on the old extruders, the Greg's Wade's 3D printer extruders. Those are just horrible.
I made a 3D printed gear and put it on my Craftsman lathe. They got a 12-inch Craftsman, and it actually ran for a while. But PLA is probably not good for gears.
Yeah, I typically used ABS for that kind of application. And actually, I was just looking. I did 3D print one gear to mesh onto the first. There's a nylon drive gear on the spindle of the Go602 lathe. That's the first stage in the gear train for the change gears. And I did 3D print a plastic gear that fit into that for the power takeoff initially for the encoder, but that just rattled and clattered and made a lot of noise. And so I put the original, I think it's a Delrin gear back, and then drove with a belt off of that shaft, and that worked a lot better, ran a lot quieter.
Yeah. I don't often print a lot of stuff with my 3D printer, but when I do, I usually print a whole bucket full. And I'll think, well, I make this variation here and then that variation there, and then pretty soon I got a pile of junk there. I'm not going to use any of it.
Well, and I think that's actually one of the things that I love about 3D printing is you can start with a design, but until you even in a 3D modeling package where you can do a full solid model and put together your assemblies and actually look at it working, until you can hold it in your hand, you can't appreciate the mistakes that you made, the things that you didn't think about in the design. And so with 3D printing, it's so simple to get something together rough that you think is close, and then just print it. And then just hold it in your hand, fit the pieces together, see what doesn't work, and then go adjust the model and print it again. And I've gotten a lot of feedback from people who say they don't understand that because it takes 4 hours or 8 hours or 12 hours to print something. And so why would I want to iterate? Wouldn't I want to get it perfect first? And there's two problems with that. One, I can't get it perfect first. That's not how it works. And two, I don't have to be there. I can just print the thing and go do something else, or go to bed, or go shoot a video or whatever, and come back 12 hours later, and I have the advantage of having a physical part I can look at. I'm also fresh because I've been doing something else with my mind rather than focusing on this product or on this project. And I just find that kind of iterative process to work really well in a way that you can't really do with hands-on machining, because you're right there. And even if you do run through the whole thing, you've invested so much time and so much effort. The idea of saying, oh, I see something that should have been different, I'll just toss that and make another one. It's just not a practical part of that process. Even though, you get to the end of 12 hours of machining and then break off a tap in the part, that still happens. But you generally, that's what I love about the 3D printing is it costs basically nothing for the print, and I can just make another one and another one and another one until I get it right.
Well, also it's the whole concept of prototyping, right? So if you didn't have that tool and you were to invest all that time and energy machining your final part the first time, and it's not going to turn out exactly the way you want it to be, but you're likely to settle for that substandard, and you're gonna use that part even though it's not what you want. And 3D printer allows you to fine tune those things, so when you actually do spend the time on an aluminum part or steel part, it is what you want it to be.
Yeah. For sure.
Yeah, and a lot of times you can use the plastic one for a while, like the carriage stop that I made a while back. I 3D printed it, and I used the 3D printed one directly for several months, and it was okay. Like, it had some flex in it, but, it was better than nothing. And but it had some angles in it that weren't quite right and stuff. So I was able to use it for a while, get comfortable with it, decide what I needed to improve on, and then I tweaked it and made one out of steel. And obviously the steel one is better, but the 3D printed one is perfectly fine. Fixtures and one-off holding tasks, like there's a lot of things for which 3D printing is great in the machine shop.
Speaking of 3D printing, there's some sellers on eBay selling these spindle protectors for the old style lathes, threaded spindles, and I picked this one up a couple of weeks ago for this new. I made a video on making this rotary table. An adapter for the rotary table. I can't find my camera. An adapter for the rotary table for my chuck, 1.5 to 8 spindle type load and lathe. And these are pretty great. They vary in prices. I guess it's what the material. I guess ABS is the best. I don't know what this is, but it's been serving the purpose. It's not going to be. Probably aluminum would probably be better, but there's printed gears and everything. My cousin got gears for his Logan lathe printed, and they're holding up. So it's a pretty viable market on the printing stuff.
Well, I mean, there are parts where plastic is the ideal material for it.
Yeah.
But now, if you're trying to machine that on a lathe, for example, I mean, just gripping power distorts the part that you're trying to machine and stuff, and you don't have to worry about any of that with 3D printer,
Right, yeah. We've made Delrin parts in the tool room, and, it's a challenge. Delrin and the black stuff, I forgot the name, acetate, but 3D printing is the way to go.
And Keith, you've done some casting, right, with 3D printed forms. Is that right? How does that work?
Yeah, that's pretty much what I use my 3D printer for, is making patterns for doing casting. So when I'm working on this old machinery and old equipment, very often, seems like more often, to do a proper restoration, I have to recast something. So I've found 3D printing to be a lot faster than traditional pattern making, particularly for these complex parts. Still sometimes I'll just go make it out of wood if it's a simple pattern. I got a pattern I need to get made this week, and I'm just going to make it out of wood because I can do it faster than I can draw it again. But for so many things, the 3D printer is awesome. And for example, I've recently started selling my little straight edges that we use in scraping, and I designed one that I liked, and it's kind of my own style or whatever. But just like James was talking about a while ago, doing the different versions and being able to hold it in your hand, you'd print it out. It looked great on the computer screen, but when you held it in your hand, it's like, well, this isn't just right. So you go modify your design, print out another one, and all that was done before we ever cast the first thing. And interesting about 3D printers, I've just recently upgraded. I've gone to one of the resin printers. I don't know if any of you guys have tried one of those yet or not, but for, again, my pattern making stuff, with the traditional filament printers, you would always get those surface finish that just wasn't really right, and I would spend hours and hours and hours trying to clean up the 3D printer, to get it because that stuff shows up in your castings. But going to the resin printers, man, that stuff really comes out nice, and I can actually print it solid. Really makes a much more dense pattern for ramming up in the sand that holds up a little bit better. So I've been really happy with that new resin printer I got. I don't think I've really talked about it at all on my YouTube channel, but it's something I really enjoyed playing around with.
Which one did you get? Which resin printer?
Oh my goodness, you would ask me that. I can't remember. I don't remember off the top of my head.
Well, I'll take this opportunity to again plug James's video on the topic of resin printers. He's got a great one that covers how they work and what to look for one, and the practicalities of using them. So that's a great video.
Yeah, I was learning all that stuff as I went and figured might as well share it. In fact, that's ultimately why I started the channel in the first place. Is just everything that I do as a hobby is enabled by people that have come before. I mean, several of the guys here on this channel that are routinely on this ARW discussion, they're guys that I watch and learn from, and things like the RepRap project. There's all these people that have come before that have built things. The Arduino community, that have made this stuff possible, and I want to then, share and give something back. And if I can take something that's not well covered, condense the information and put it in a form that then is going to be useful for somebody to come along and find, like what I wished I had been able to find when I was trying to learn it, that's something that I can do. And that's kind of how I got started on that.
Well, I tried one time to mess with the model making stuff a little bit. Things were just too tiny for me. I'm too fumble fingered. I break off the little tabs and things like that. I had a number 4 tap in a piece of aluminum that I was trying to make a wobbler engine like Mr. Pete did. I flicked my hand backward like that, and bang, there goes the tap, broke off in my part.
I'm with you, Harold. I would much rather work on a part that was thousands of pounds than something that you had to look at through a microscope to make.
Well, I just can't fathom
so much easier to me.
Absolutely.
Yeah, I mean, I do a lot of model making on my channel, but I definitely have a lower size limit. Like, I don't know, I'm sure a lot of us follow the Swiss Toolmaker on Instagram, and the stuff he does, like he literally has, microscope loops mounted on his machines, and the stuff he does is so unbelievably tiny. Yeah, I can't do that stuff. I mean, the last steam engine that I built on my channel is about as small as I will go. The smallest tap on that project is 256, and it's very stressful trying to tap cast iron with 256. And I don't like going any smaller than that. The parts just get too hard to hold and too hard to tell if they're straight because there's no surfaces to indicate on. Everything's so small. So
yeah, but Quinn, if you don't know if it's straight or not, I mean,
well,
it can't be wrong, right?
The engine will know when it doesn't run very well. It's funny. That's the other challenge with the really small stuff is that on those model engines, the smaller they are, the more critical all the dimensions and precision is. A larger engine, if the crankshaft is a thou off, it'll still run fine. But those little tiny engines, like everything has to be perfect or they don't run. And so there's definitely a lower size limit for that reason as well.
One of those larger engines, if the crankshaft's off a quarter of an inch, it'll still run. Steam engines are pretty low tech in the grand scheme of world, and it's amazing. It's amazing what you can get to run with a steam engine.
Yeah, well, I tell people that a lot. That's what I think they make a great learner hobby project for that reason, because they're extremely forgiving. Like, yeah, they'll always run. They may not run super great. They may not be fuel efficient and whatever. But I mean, if you make the parts and they fit together, it'll run. And you might have to put 20 psi on it, but they're nice that way compared to like internal combustion engines. Like a lot of model makers build those, and I haven't tried that yet because those have to be absolutely perfect or they self-destruct.
They're definitely, it's a different ball game.
Yeah, for sure.
Well, that kind of goes back to CNC too. Is CNC, you got to specify pretty much everything, versus manual machining. Some of the decisions are made for you. just from the human factor aspect of it, right?
Yeah, I missed that tolerance, so we're going to make it bigger or smaller.
That's the nice thing about being a hobbyist is if you blow one dimension, you can just make the other part larger or whatever, and it'll still fit. It's like it's nice to have that luxury as a hobbyist.
Make the hole first, and then turn the shaft.
Yeah, exactly. I talk about that on my channel. Like, anytime I have two parts that fit together, I figure out which one's harder to make that one first, because then if I screw it up, I can make the other one fit.
That's true.
Yes, I do surface mount soldering occasion. That'll make your eyes go cross-eyed. I've got to bust out the microscope and.
I really enjoy it. That's something that I've always soldered with leaded solder. If I can get the 6337 eutectic stuff, or I've actually got an old roll of Kester 44 with the rosin. That stuff was beautiful, but
love the Kester. That's my fave.
But I did just recently decide, okay, screw it. I'm going to learn how to do lead free, and got the lead free solder. I've got a binocular microscope. I've got a good temperature controlled iron, lots of flux, and just grab some of these little practice boards you can buy on Amazon, come with all the parts, and just learned to do it and learn to do it well. And it takes a little bit of time, but then once you get the hang of it and kind of figure out how to work the fluid dynamics of the liquid solder, it's a really powerful skill. And I enjoy it. I enjoy just getting under the microscope and working, because you can't even, like I can't even see the parts, but under the microscope you can see it. And since I care about doing it right and having it look pretty, I can do that. And it's something that I don't know, I just find it really satisfying when I have something like that. At the end of the day, you look at it and say, well, that came off an assembly line. There's no way that was hand soldered.
Yeah, I was surprised when I first got into SMD that how much the binocular microscope enables you to do. Like, I think a lot of people don't appreciate that magnification effectively increases your dexterity. Like, people think, oh, I don't have steady enough hands to do that stuff. You actually don't need steady hands. The magnification, like your brain just adapts or something to it, and you can do more than you think you could with.
Well, and you also, if you brace the heel of the palm of your hand on something, then you're just using your finger dexterity. If you're trying to hold your arm out, there's no way.
Yeah, but it is amazing. You look through that microscope, and the whole world, it's like, it just suddenly seems possible. This thing that, there's no way I could solder something that small. But once you're looking through that scope, it's like, oh, actually, I can
and once you get your head around the idea that you're not putting something in place and then putting solder on it, you're flowing the solder in, and the surface tension of the solder is doing the work and locating the components. And once you get your head around that, then everything makes more sense at that scale. Yeah,
the physics is sort of magic. The solder knows where to go.
I don't come on, you guys make me want to buy a microscope now.
I don't have a binocular one. I've got I've got access to one at the space, but I use the little cheap LCD one, and that one works great for most of the stuff I do. What I was showing off here a second ago, this is a smart soldering iron. It's the Peinzel. It's an open source soldering iron.
That's the USB one?
It's USB-C. It's intelligent. You put it down and leave it alone for a minute or two, and it'll drop down to 300 degrees. You pick it up, and it shoots back up to your predetermined set. You let it set out for an hour, and it turns itself off, so you don't burn the tip up or burn the house down. I'm starting to really like it.
Does it recognize if you step on it?
I don't think it really cares. I think it'll burn a hole through you just the same.
I have some scars.
Yeah, a low budget option also that I think people might be interested in is, so I talked about this a bit on a blog post I did about this. I replaced the chip. It was a 0.5 millimeter pitch surface mount chip on a device that I'd burned out. And I did it entirely by I mounted my cell phone above the board with one of those like cheapo Amazon glue-on macro lenses, those little clip-on macro lenses.
Yep.
And then just so you can like pinch to zoom in a little bit on your phone. And that works surprisingly well. I did melt the side of my phone a little bit when I touched it with the iron, but otherwise you don't have a lot of space to work between the phone and the board because the focal length on those lenses is very short. So you're working in a small vertical space. But yeah, that also worked surprisingly well. I didn't really expect it to work, and it did.
I don't know how many times I've used my cell phone to identify components. That's just
the older I get, the more I do that.
I was going to say, I never could have imagined in my younger days that the topic of magnification could be such a riveting topic for me. And as I got older, I see all these, the visor.
Yeah, the jeweler's visors are magic.
Yes, and I see all those. There you go, Quinn. Yeah, I see those, and I actually get excited.
Things are great. Like,
and,
oh my
gosh.
God.
I get disappointed that I don't get one for my birthday. You know what I mean?
What'd you say, Yuko? What'd you say?
Yeah, you look like a giant dork, but once you get used to these things, it's like you don't want to work without it. It's like you can just see so much more.
Right.
So these are the ones similar to the ones Chuck had on his video a couple weeks ago, but these are slightly newer. These are lithium rechargeable, so they're a little lighter weight, which I appreciate. Having 2 or 3 batteries on my forehead doesn't feel good, but that thing's ultra light, so I liked it.
Now, if a seller packages those with longer arms for you so you can hold the parts further away from you, now that would be a winning combo. I would buy that tomorrow.
And that ultimately, that's what the jeweler's visor does for you, is it allows you to focus up close. So you can bring it in and you can focus clearly and see. And it's magic. They're great for soldering.
Awesome.
Hey, there's
Dean.
Hey, Dean.
Hey, Dean.
Guys, I don't know how my service is up here. I'm way up in the mountains.
Oh,
wow!
You must be with
gone.
Dale. Dale's always out in the mountains.
yeah.
Yeah.
You're running a little late.
Grabbing.
I'm going to have to get some of those visors too. I had a USB microscope, and I really loved it. I could use it to get all the steel out of my fingers, after I played out in the garage. And I had a crash on my computer, and I lost all the software. And I never could find any software to run that stupid microscope anymore. So the other day, I finally just tossed it in the garbage.
Oh, that's sad.
That is sad. I thought those things used pretty generic drivers. I wouldn't have thought you'd have to have anything special to run it.
I downloaded piece of software after piece of software. None of them would work with it.
And
it was amazing.
I use Linux, so half of that's taken care of for me. And when it doesn't work,
you just have a limited range of products. You have to buy one that works with Linux, and then you're good.
Right. Actually, I've got a problem. I bought some new Rode Go 2 microphones, and I don't have a Windows or Mac machine to run the software to change some other parameters. I got to figure that out.
Yeah, I did want to respond to one of the comments that went by earlier, complimenting me on the motor torque videos that I've done the last couple of weeks. And I got to tell you, that's something that I did it because it's just fascinating to me, and I didn't have answers, and I didn't trust manufacturer specs. And, I think that's also something that nobody really does, right? If you go look at the videos out there, it's like, hey, I got this new motor, set it up, watch it spin around. This is great. Here's my link, go buy it, and I'll get a commission. But nobody actually tests them. And now I think I know why. If you look at the views on those videos, it's likely to sink my whole channel here. But I just find that interesting because I think that's actually one of the larger pieces of value I've put out there. But in terms of performance of the videos, it's just tanked. It's really interesting to see that. And if I did something real snappy with music, montage, wow, look at the thing I made, I'd get more views, but I don't feel like I'd be making anything useful.
I don't know. When I see these videos that have got a lot of music, I mute the thing. And if the person ever says anything, I don't know about it, but I just can't tolerate the music.
Yeah, and then you look down at the bottom and they got 600,000 views.
Yeah, I don't understand that.
A lot of it is just juice in the algorithm too, right? Like, like this old Tony is awesome. We all love him, but I mean, he's at a point now where like he can put out a 7-minute video about patching a hole in the muffler on his trials bike, and it does 600,000 views, right? And anybody else does that video, it's going to do 2,000 views. So there's a certain threshold I think you cross in the algorithm where everything you do is just gold at that point. It's just like a self-fulfilling prophecy.
And the last 2 weeks, you do anything talking about UFOs, and bam, million views. Doesn't matter what you say.
Really?
Actually, probably get done with it better.
I'll have to keep that in mind. Maybe I'll do a video on UFOs.
How to
make a little miniature UFO out of aluminum or something.
Yeah, replica UFO.
Okay, guys, y'all, appreciate you just logging in and making all these nice comments. I'm hoping you'll be back next Sunday, and maybe we'll have something equally interesting for you then. That's the end of the live stream.